Part 2 of Lesson 3 on Chapter 1 is on end behavior. End behavior is a concept that you initially learned in Algebra 2 about the ends of the graph. And I like to say that some graphs look like a touchdown guy, both ends going up. Some graphs look like what I call a gorilla guy, both ends going down. Some graphs look like what I call a disco guy Randy, where the right side goes up and the left side goes down. And some graphs look like what I call a disco guy Larry, and that's where the left side goes up and the right side goes down. And then some graphs look like what I call an airplane guy. And sometimes you have graphs where it flattens out on both ends, kind of like that. Nevertheless, when we talk about end behavior, this is the notation that you used last year. So this is read as the function approaches infinity as x approaches negative infinity. What that means is as you go to the left, the function's going up. Consequently, right here, how this is interpreted as the function goes up as you go to the right. And you can see that with the touchdown guy, whether you go left or right, the function's going to go up. We'll come over here, and this is describing the left end, and that's saying as you go to the left, the function's going down. And then this is describing the right end of the graph. As you go to the right, the function goes up. So that's what you used in Algebra 2, but we're going to use some slightly different notation in pre-calc. And this is how we're going to write the left end behavior. We're going to use limits. And you can see for the left end behavior, you're going to say the limit of the function. And underneath that, you're going to have x with an arrow approaching negative infinity. What that means is go really far to the left on the graph. And this is how we're going to describe the right end behavior. We're going to say the limit of the function, and underneath that, you're going to have x with an arrow approaching positive infinity, because that means go really far to the right. So here's an example of a graph. This is what I would call a gorilla guy. And so every time you do the end behavior of a graph, you need to write this. Limit of the function as x approaches infinity. This is describing the right side of the graph. And so on this particular graph, the right side's going down, so I'm going to answer with negative infinity. We also need to write limit of the function as x approaches negative infinity. This is now describing the left side of the graph. And if you go really far to the left, the graph is also going down. Therefore, I'll put a negative infinity on the left end notation. So the blue represents the right end, and the red represents the left end. Here's another graph. So again, describing the end behavior, we're going to say the limit of the function as x approaches infinity. This is the right side. You can see that the right side is going up. We're going to say positive infinity. And now we describe the left side by saying the limit of the function as x approaches negative infinity. And you can see the left side's going down, so we're going to have a negative infinity there. Again, the blue notation is describing the right side of the graph, which happens to be going up, and the red happens to be describing the left side of the graph, which happens to be going down. Here's another graph. You can see that the right end is going down, so we'll answer that with negative infinity. And the left end is going up. So that's how we write the end behavior. Again, blue represents the right end, and the red represents the left end. Now here's a unique graph. This is what I would call an airplane guy. So as we describe the right side of this graph, you can see that it's flattening out. It's getting closer and closer and closer to 0. And the same thing is true for the left side of this graph. It's getting closer and closer to 0. Now the right side is getting closer to 0 on the positive side, and the left end is getting closer to 0 on the negative side underneath the x-axis. Here's another example of a discontinuous function, and so if we describe the end behavior, we have the right side getting closer and closer, or flattening out at a height of, I would say, 3. And the left side, I would describe it as flattening out and getting closer and closer. Also, that's not -3, it should be +3. Because if I were to draw a horizontal line at +3, you can see that the graph is approaching that red dashed line on the right side as well as on the left side. Here's another unique graph. If we're describing the end behavior using our limits notation, we would say the right side flattens out at a height of, I would probably say that this is getting closer to -3, because if I put a horizontal line at -3, you can see that the graph is getting closer and closer to that horizontal line. And so now to describe the left side, it is also getting closer and closer to -3. So this is how we describe end behavior using limits of continuous functions and discontinuous functions.